When you think of Jupiter, you probably just picture one giant planet, right? But what if I told you you're actually looking at an entire solar system in miniature? A place with a cast of characters so diverse, they challenge everything we thought we knew about what a moon could be. And that's really what we're going to dive into. Because tucked away in this little system, one of these moons might just be hiding the biggest secret in the entire solar system. The answer to that huge question, are we alone? I mean, the scale here is just wild. Jupiter has 97 known moons, 97, and that number keeps going up. But for today, we're going to focus on the four real heavyweights, the ones that completely changed how we see the universe. Yeah, these are the famous Galilean moons. Back in 1610, when Galileo Galilei pointed his telescope up and saw these four little dots, it was a revolution. It completely shattered the old idea that everything had to orbit the Earth. So let's meet the family, shall we? You've got Io, a volcanic inferno; Europa, a mysterious ice world; Ganymede, an absolute giant; and Callisto, the ancient battered survivor. Each one is a totally unique world. All right, to really get a feel for this system, you have to start with the most extreme member of the family. Let's talk about Io. This place is, well, it's a world of pure fire. I'm not just talking about a world with a few volcanoes. Io is the single most volcanically active body in the entire solar system, full stop. So what's causing all this chaos? Well, it's basically a relentless cosmic tug of war. See, Io is trapped. It's getting squeezed by Jupiter's insane gravity on one side, and then it's getting pulled by its neighboring moons on the other. All this constant stretching and squeezing generates an incredible amount of heat, enough to melt the very rock deep inside the moon. Okay, to really get a grip on the power we're talking about, let's compare it to Earth. The biggest ocean tide we have is, what, maybe 18 meters? That's water. On Io, the solid rock surface itself bulges up and down by as much as 100 meters. 100! That's like watching a 30-story building rise and fall every single day. That's the mind-bending power we're dealing with here. And all that tidal heating creates, well, a truly hellish landscape. Io's surface is constantly being paved over again and again by hundreds of active volcanoes. They're just spewing out all these sulfur compounds, which is what gives it that bizarre kind of pizza-like colorful look. The atmosphere? A thin, toxic soup of sulfur dioxide. And water? Nope, not a drop has ever been found. So yeah, between the nonstop lava and the brutal radiation blasting it from Jupiter, Io is pretty much the last place in the solar system you'd go looking for life. But here's the twist. That same extreme heat is the key to the incredible possibilities we find just next door. Because as we move out from Io's inferno, we find something absolutely stunning. That same tidal energy, the same force that melts solid rock on Io, might be doing something even more amazing on its neighbors, creating huge, hidden oceans of liquid water buried under ice. So you've got three of the Galilean moons, Europa, Ganymede, and Callisto, and all of them are potential candidates for these hidden oceans. But right away, one of them just jumps off the page. Europa. It looks like it has a pretty thin ice shell, at least compared to the others. And underneath it, a massive, massive ocean. That makes it our #1 target, for sure. And that brings us to Europa. For decades, this little moon has totally captured the imagination of scientists, sci-fi writers, pretty much everyone. And it's all for one simple reason. It might just be our best shot at finding life beyond Earth. And listen, this isn't just hype or science fiction. This is a conclusion built on decades of solid evidence. Pretty much everything we've learned about Europa points to a world that checks all the right boxes for life as we know it. Seriously, try to get your head around this number. Scientists estimate that Europa's hidden ocean could contain twice as much liquid water as all of Earth's oceans combined. Let that sink in. Twice our planet's water, in a vast, global ocean, totally hidden beneath a shell of ice. So what do you actually need for life to get started anyway? Well, astrobiologists have this kind of simple recipe. You need 3 key ingredients. Number 1, liquid water. Number 2, the right chemical building blocks, things like carbon, hydrogen, nitrogen. And number 3, an energy source. So the billion-dollar question is, does Europa have all 3? Okay, let's start with the water. The evidence here is super strong. See, as Jupiter's powerful magnetic field washes over Europa, it creates a second, weaker magnetic field inside the moon itself. The only way that really makes sense is if there's a huge layer of something that conducts electricity under the ice, something like a deep global ocean of salty water. So, ingredient number 1, check. All right, so what about the other 2 ingredients, the chemicals and the energy? Well, remember that tidal flexing that tortures Io? It's happening on Europa too, just not as violently. And that gentle squeezing could be creating hydrothermal vents on Europa's seafloor. Think about it. Just like the deep-sea vents we have on Earth, these would pump out key chemicals from the moon's rocky core right into the water, and they'd provide a source of energy, totally separate from the sun. So that's ingredients 2 and 3, check and check. And the evidence just keeps getting better. Europa's surface, it's weirdly young and smooth, almost no craters. That means something is actively repaving it. Then you have these bizarre chaos terrains. They look exactly like places where the ice shell has cracked and huge chunks have just floated around and then frozen back into place. But the most exciting clue of all, we've actually seen what look like giant plumes of water vapor shooting out from the surface into space. Basically free samples from the ocean below being blasted out for us to find. But look, as incredible as Europa is, the story doesn't stop there. The other moons are just as wild, each one a record breaker in its own way. It really hammers home just how special this little solar system around Jupiter is. Okay, next up, let's talk about the king of all moons, Ganymede. This thing is an absolute monster. It's not just the biggest moon in our solar system, it's literally bigger than the planet Mercury. Seriously, if Ganymede were orbiting the sun on its own, we would call it a planet. No debate. And because it's so massive, it does something unique. Ganymede has a molten iron core, kind of like Earth's. And that spinning liquid metal core generates its very own magnetic field, what we call a magnetosphere. It's like having a personal force field that shields it from dangerous radiation. Now, think about that for a second. We found something like 200 plus moons in our solar system. And out of all of them, Ganymede is the only one that has its own magnetic field. It is completely in a league of its own. And that brings us to our last stop, Callisto. And if Io is the world of constant, violent change, Callisto is the complete opposite. Its surface is one of the oldest things we've ever seen. We're talking 4 billion years old. Because almost nothing has happened there geologically, it has perfectly preserved a record of all the asteroids and comets that smashed into it in the early days of the solar system. It's a perfect cosmic time capsule. So, what's the big takeaway from all this? I think it's the sheer mind-boggling diversity. You have 4 moons, all orbiting the same planet, but they are 4 totally different worlds. You have a volcanic hellscape, a prime suspect for alien life, a moon bigger than a planet with its own force field, and a frozen time capsule from the dawn of the solar system. It really is a perfect solar system in miniature. And that brings us right back to where we started, to that big, big question. Because if we ever do find something alive in Europa's dark ocean, it would mean that life got started all on its own twice in the same solar system. And if it can happen twice, right here in our own backyard, well, it makes you wonder, doesn't it? Just how common could it be out there, sprinkled across the billions and billions of other stars in our universe?